This is the second part of 4.1. So you have a quiz next Wednesday over 4142. All right, so we're going to do 4.2 on Monday, Tuesday. Get ready for our quiz. But we're going to talk about two different formulas today. This one is linear speed, and we're going to talk about angular speed. This is a really simple concept. There's just a couple things that are super duper important that you have to remember. All right, if you have this formula right here, this is the formula for arc length. You guys need to know this right here. S equals R times theta. Okay, arc length is S equals R times theta. Does everybody see that?
And 0 is...
That's theta, okay? Does everybody see S? So S is your arc length. S equals arc length. What does arc length mean? Anybody know what an arc is? Like here's my circle, right? And then I have here, this is your arc.
Yeah.
Like the crust of the pizza. So we're talking about arc length. Okay, so R is your radius. R is your radius. And theta is your central angle. Now, the most important thing I can tell you from this is when you're calculating arc length, your central angle has to, super important, has to be in radians. How do you think 90% of the time they're going to give you your central angle? If it has to be in radians, what are we probably going to give it to you in? We're going to give it to you in degrees, and you're going to have to do what? Convert it. Okay, so you'll have a problem like this. A circle has a radius of 4 inches. Find the arc length intercepted by the central angle of 240 degrees as shown in the figure. So remember, your formula for arc length is S equals R times theta, correct? We're looking for arc length. If they give you the arc length and they give you the radius and you solve for theta, then you just solve like you would any other formula. Plug in the stuff that you know and isolate the thing that you're trying to find. But if I'm trying to find the arc length, I have all of the information. I don't have to have a picture. They could just give me the information in words. But what is my radius here? What is my R? It's 4 inches, right? What is the central angle? What is the theta that they gave me? 240 what? Degrees. When you calculate arc length, guys, what is your theta? What does your central angle have to be in? Radians. A lot of you will forget to convert. If you forget to convert this to radians before you figure out the arc length, then your answer's wrong. So we have to convert. Convert this to radians. Where does 180 go and where does pi go? 180 on the bottom, good. And pi where? On the top. So right away, my degrees cancel out and my zeros cancel out, correct? What can I cross cancel between 24 and 18? 6? Yeah.
Yes.
Yes or no?
Yes.
Okay, 6 goes into 24 how many times? 4 times. And 6 goes into 18 how many times? 3. So your theta that you're going to use to calculate your arc length is what? 4 pi over 3. Now, the rest of this is super simple, but if you don't remember to convert your central angle from degrees to radians, then you get your answer wrong. So as you guys are now going to find the arc length, it's radius, which is 4, times your central angle, which is 4 pi over 3. Well, what is 4 over? 1, right? 4 over 1? You're just multiplying two fractions together. So what is 4 times 4 pi? 16 pi over what? Over 3. If they tell you to keep your answer in terms of pi, that's your answer. How do you know it's in terms of pi? What do you see there? The pi symbol. If they want it to the nearest decimal, what you would do is in your calculators, say nearest decimal. In your calculator, you hit 16 times pi, enter, divide by 3. So what would that be in decimal form? What do you guys get that? Yeah. 16.755? Okay, all right, good. Does anybody have questions on that? Like, think about that. S equals R times theta. If they gave me S and they gave me theta, how would I find R? Divide by sides by theta, right? And you get R equals. It's just manipulating formula, just solving. Nothing crazy. Next one I want to talk about is linear speed. Okay, we're going to talk about linear speed here. We'll talk about angular speed later, but we're going to talk about linear speed. Here's the formula for linear speed. It's a little bit different from our arc length. What's the thing that's a tiny bit different? The time. You're taking what we just did, which was arc length. Arc length is R times theta, right? And you're dividing it by a specific time period. So all you're doing is doing the same thing with arc length. R times theta. What does theta have to be in? What does theta have to be in? Radians. And you're dividing it by the time they give you. 90% of the time when you're asked to find linear speed, guys, they use a clock. Because the clock is what shape? A circle. Okay? So if you're finding the linear speed, all right, linear speed. Linear speed. It's how fast something goes around. It's arc length over time. So it's the same thing as R times theta divided by the time period that we're talking about. So if you look at this clock, everybody see this nice round clock. Okay, we're going to talk about time periods here. But what we do know is that the second hand of the clock is 10.2 centimeters long. What value are they giving you there? The R, the theta, or the T? If I know that from here to here it's the R, it's the radius. When they tell you how long the second hand is or something like that, that's from the middle to the outside. So it's 10.2 centimeters, right? Now they're asking you to find the linear speed of the tip. How fast does this go around in a circle? They're giving you, when they tell you how fast it goes around, they're telling you the central angle and they're telling you the time period because it's a circle. So let's think about this for a second. I'm going to draw 4 circles. 2, 3, 4. Okay? We're going to talk about circles, just what we know. How many radians are in one whole circle? All the way around. It's 360 degrees, but what's the radian? No, but I'm sorry, in pi, in terms of pi. 2 pi, okay? How many would be in half of a circle?
2 pi.
No, one whole circle is 2 pi. So we'll say this is one whole circle, this is 2 pi. So 1/2 of a circle would be pi. What about a quarter of a circle? 1/2 of the pi, so pi over 2. What about if I had 3/4 of a circle?
2 over pi.
Not 2 over pi.
Pi over 2.
3 pi over 2. Would you guys agree with me that one whole circle is 4 pi over 2?
Yes.
3/4 of a circle is 3 pi over 2.
Yes.
Half of a circle is 2 pi over 2. And then a quarter of a circle is 1 pi over 2. Right? We just cut it into 4 pieces. And when we simplify 4 over 2, that's where we got our 2 pi. When we simplify 2 over 2, that's where we got pi. Okay, now let's talk in terms of time. If I take a second hand and I go all the way around the clock from 12, the second hand, and I go all the way around, how many seconds did that take?
60.
60 seconds. If I go from the 12 to the 6, that's halfway, right? How many seconds does that take? 30. If I go a quarter, if I just go from the 12 to the 3, how many seconds is that? 15. And if I go from the 12 all the way around to the 9, I go 3/4 of the way. How many seconds is that? 45. So when you're talking in terms of a circle, and again, a lot of times they talk about time on a clock. This is the time that they're talking about in seconds. And then this is your central angle. This is your theta. Did I go all the way around? Did I go halfway around? That sort of thing. So depending on how the question is worded, they're going to give you the time and the central angle, depending on what they're asking. This question asks, how long does it take for the second hand to go all the way around? Well, which circle represents going all the way around? 2 pi. So you would figure out the linear speed here, and you'd say, okay, my linear speed is arc length, which is radius times theta. Well, my radius, you said, was 10.2, right? Times theta. If I go all the way around, what's my theta? 2 pi.
Over 67.
Divided by how many seconds? 60. And we do that in our calculator. What do you guys get? Do 10.2 times 2 pi. Hit enter, then hit divided by 60. You guys got 1.068, you said. Let me write that. 68. So it's centimeters per second. All right, let's use the same clock. I'm just going to do a different example. I'm going to do the same clock. So my radius is still 10.2, right? But now I want to see how fast this second hand goes just halfway around, a half revolution. Well, when I say a half revolution, what is my theta and what is my time? Pi is my theta because I went halfway around the clock. And what's the time? 30 seconds. Good. So, again, we're going to find linear speed. So it's 10.2 times pi this time divided by 30. What do you guys get? You got 1.068 again?
Yeah, we got the same thing.
Huh, okay. Well, let's see what happens if we go 3/4 of the way around. So think about it. My radius here is going to be 10.2. But now I'm going 3/4 of the way around. So what is my theta if I go 3/4 of the way around?
3 pi divided by
3 pi over 2. And what is the time that I'm going to use? 45 seconds. So be careful in your calculators, guys. You have 10.2 times 3 pi over 2. And then you divide that by 45. Do the numerator first. Hit enter.
same thing.
Do the numerator first. Hit enter. Like do 10.2 times 3 pi over 2. Put the 3 pi over 2 in parentheses. Then hit divided by 45. What'd you get, Sean? 1.068. Guys, why do we keep getting the same answer?
Because it's a circle.
Because, okay, it's a circle. What else, though? Look at the clock. Watch the red hand go around the clock.
Oh, because it moves at the constant rate.
It moves at the same rate. Good. Does it speed up? Does it go between 12 and 3? Does it go real fast? I know it seems like some days in here it goes really, really, really slow. But it really moves at the same rate all the way around, right? So when they're asking you these questions and they keep the radius the same, but they ask you at different portions of the clock, you should come out with the same answer. But what is the most important thing you can take away from this? When I give you your radius and your theta and all that stuff, what do you have to remember to do first? Convert the theta, central angle, convert from degrees to radians. That is so unbelievably important because if you guys don't do that, you won't get the answer right. Does that make sense?